Okay, so now we're going to do another word problem, and this is more like data fitting, and we're just going to do the part 1 of this, and then tomorrow we'll do the next one where we actually use a matrix to solve it. Okay, so today we're just learning about Desmos and using how to graph in it, and this one's really interesting in Desmos because you learn how to do the vertex form and kind of messing with it. All right, so a company is testing a new moped design. The data shown in the table is the cost C of driving, so that's these, the cost C of driving a moped at different speeds, V, in miles per hour. The cost in dollars includes fuel and maintenance for driving the moped 100 miles at that speed. How much is the predicted cost of driving the moped at 10 miles per hour? What is the optimal speed to drive the moped? Justify your answer. So whenever you see JYA, that just means justify your answer. Okay, which means complete sentences. All right, so first we're going to go to Desmos and we're going to graph these. And that's why I gave you this area here too, so that you could justify using your graph, okay? All right, so we're going to go to Desmos. All right, and obviously we can't just type in a function because we don't know the function. So we're going to hit the add and we're going to do a table instead. Okay, and then I'm going to type in the table. The x values is v because that's the velocity, and the output is your cost. So that's interesting that your velocity is not your output, it's your input. So we're not doing time here. It's how fast you go related to how much it costs you. So 15, then I'm just going to hit the enter button. 25, 35, and look at that, it counts for me. 45, 55. Okay, now I'm going to come back over here and type 10.35, 9.05, 9.35, and then look at that, it jumps back up. So somewhere it's getting between 25 and 35 is my guess. 11.25 and 13.25. Okay, and then they should be graphed, but I don't see them. Well, that's because look, I'm only going to 10. Where's my first x? 15. So I'm gonna go this way and you just kind of drag and pull it. Okay. I need to get all the way up to like 13 for my y's. Oop, I found one. But I need to get, yeah, so let me see. So let me keep zooming out. Oh, there we go. And I have like a little rolly thing on my mouse, so I can like zoom in and out doing that. Okay, but you don't have to. You can also hit the zoom out buttons. Okay, so I should have 5 points. I see 3. Oh, they're there. 1, 2, 3, 4, 5. And then I'm going to zoom in a little bit until... Okay, if I go any farther, I can't see my x-axis, and I really need to see my x-axis. Okay, so that's good. All right, now this, do you see how it's like a curve like this? So that's got to be the parabola shape of it. All right, so that means I'm going to need to type in a parabola. So y equals A, and I'm going to do it in vertex form because that's the easiest one to mess with. So we're going to type the vertex form of a parabola. X minus h, close it, and then squared plus k. And it says add sliders, and I want to add sliders for all of them because I need to like make this. See, now watch. If I do, ooh, if I go negative, if I go positive, and then right, ook, but it stopped. And then also up. That looks good. Okay. So it looks like my K values are fine, but I need to get it over there, and I need to get it wider. Ooh. Okay, and see how it flips suddenly because it's counting by like point 0.1. There we go. Okay, so I'm going to go to settings up here, and I'm going to mess with these. I don't need any negatives A's, so I'm going to go 0 to 1 really because I'm trying to get it, like I'm trying to do a decimal, and I already have it at 0.1, and it still doesn't look like it's wide enough, right? And then I'm going to do like, I don't know, 0.01. Okay, let's test that. See if we can get it wider now. Yeah, there we go. And then that's it. Flat line is 0. Okay, so that might be wide enough. If not, we'll add another 0 in there. All right, and then H, I need to go right. So 0, I need to go to like 30. So, and then a step of 1. All right, so then now let's go here again, click on that, and then try to get it over there. That looks good. All right, let's go to the settings again. Maybe just go to like 40 just in case I need to go past it. All right. Click on that to get the sliders back. And then, yeah, but that looks pretty good. All right, and then you just want it to like basically get the shape of it. So if you need to go up, and that looks even better. And just kind of mess with it. Too far. That looks pretty good. Okay, so it's not gonna be perfect. They're not gonna line up perfectly. We will learn tomorrow how to do perfectly, okay, to find our actual quadratic regression. But today is just playing with the sliders here. So I'm gonna plot the points. So I need, I only need to go up to like, what does that say? Up to 20, not even really. I really just need to be around 10. They're all kind of hovering around that, right? And then my x-axis, I do need to go far in my x-axis. I'm gonna count by 10s, okay? And again, when we graph, we're gonna graph in pencil in case we screw it up. So 10, 20, 30, 40, 50, 60, 40, 50, 60. Okay. And then I need to go up to 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Great. I can count by ones here. Okay. So then 15. 10.35. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and a bit. 25 and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 35 and also, so 9.3. 2, 3, 4, 5, 6, 7, 8, 9 and a bit. And then 45 and 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.25. And then 55 and 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, and then we can draw our picture, and you're just going to kind of estimate it from your Desmos one. It's no big deal. I'm going to kind of go above this a little bit. And then what? Below this one, and then well below that one. So it looks like our vertex is at 30. 8.5. So 30, 8.5. 1, 2, 3, 4, 5, 6, 7, 8.5. So we're gonna go like this, and then there, and then what? Go way below that one, and then slightly below, and then above. And don't connect over there to the y-axis, because that y-axis intercept is at what? 17, which is off of our picture. So that's how that should look. Okay? All right, and then we just say that we found the, we estimate the equation to be C equals, because C is the output. All right, and then it's A, so 0.01, and then V is X, so V minus H. Well, I'm just getting these off of here, right over here. H is 30 and K is 8.5. So minus 30 squared, don't forget that squared, plus 8.5. Okay. All right. As graphed to the left. Okay. All right, and then it says, what is the optimal speed? Well, the optimal speed would just be the minimum cost, right? So then the optimal speed is at the vertex, which is, and we found it on Desmos here, 30, 8.5. There we go, 30, 8.5. Okay. i.e. 30 miles per hour at a cost of $8.50. And there we go, and that's a justification as well.